Afternoon, ladies and gentlemen. We're about to start. We have Jeff Tranter from ICS, who's presenting a talk on Qt on the Raspberry.
Okay, good afternoon, everyone. So I'm going to be talking about Qt on the Raspberry Pi. It's not going to be a really technical presentation. I'm going to assume you don't really know what a Raspberry Pi is, so I'll tell you a lot of the background about Raspberry Pi, where it came from, where it's going, what the capabilities are, and then I'll talk a bit about Qt and the current status of Qt on Raspberry Pi. So we'll talk about just what a Raspberry Pi is, the Raspberry Pi Foundation that is behind the development of the product. So we'll talk about the hardware capabilities, the software that's available. We'll talk about some of the different Linux distributions are available, including the QtonPi distribution, and then I'll talk about the current status of Qt 4 and Qt 5 on the Raspberry Pi. Talk a little bit about the supported input devices on for the hardware and output devices, status of things like touch screens, and also kind of briefly touch on some of the similar devices that are out there that you can think of as kind of competitors to or alternatives to the Raspberry Pi. And then just kind of some miscellaneous issues and things you may find of interest. And then we'll talk a little bit about where things are going in the future, and give a short demo and give you some references to getting some more information. So we should have some time at the end for some questions. Try and answer those if they're not too technical. So let's talk a little bit about where the Raspberry Pi came from. The founder of, or one of the founders of the Raspberry Pi Foundation, Eben Upton, took a quote from here, kind of explaining what he saw as a perceived problem in the computer industry, not just in the UK where he's based, but kind of worldwide. And if you think back to a lot of people who do programming now, a lot of us kind of cut our teeth on some of the early microcomputers, maybe in the 80s. In North America, things like Apple computers and Commodore 64 computers and things like that, or in the UK, computers like the BBC computer and Acorn computers. And there really isn't kind of the same kind of device out there now that's very low cost. A lot of these early computers came with a simple programming language built in, typically something like BASIC, that people could get started on and kind of get some concept of what programming was about. For example, Linus Torvalds started, I think, with a Commodore 64, and that kind of got him started on programming and on the way to being a developer. So a lot of this, the idea of this Raspberry Pi and the program was to get low-cost computers in the hands of younger people and get them more interested in programming and understanding what programming is about. Because with the lack of people getting started at an early age with programming, it means fewer people are there at the university level, and then that ripples down to the industry where we have fewer software developers in a lot of parts of the world. So this Raspberry Pi Foundation was formed a few years ago. It's a non-profit British charity, and its goal really is to promote computer science in schools. And it's quite a small organization. There's only one full-time paid employee and a number of volunteers. And as I'll discuss later, they don't really have the resources to actually build the devices, so they've licensed that out to a couple of distributors. So these are really the kind of the people behind the development of this. So it's not kind of your typical commercial product, although a lot of people are using it, in different ways beyond what they envisioned as an educational tool. So specifically the Raspberry Pi, it goes back a few years where the guys in the foundation were looking at different hardware architectures for what was feasible for a low-cost computing platform. They looked at a number of alternatives, but they eventually started looking at the ARM architecture. And this has really kind of leveraged some of the trends in the computer industry, particularly something called system on a chip, where they can now integrate a CPU, graphics chip, and memory on a single package and bring the cost down to be much less expensive than it was in the past. So this is really leveraging this system on chip technology to bring the cost down and the size and complexity of the product. So they focused on a chipset from Broadcom, the BCM2835 system on a chip, and started producing the first alpha boards just a little more than a year ago, in August of last year. And then the beta boards came out towards the end of 2011, which were pretty close to the final design. So that led to the first batch of boards. There were some delays at that point looking at how to handle the large manufacturing of these, and this is where they made the decision to go to a couple licensed manufacturers. So the first batch of about 10,000 boards came out in March, and then manufacturing started kind of ramping up from there. So the initial demand was actually a lot more than they expected. So they moved to licensing this to a couple different manufacturers that had a worldwide sales organization, and even with that, they were just unable to keep up the orders. Both their websites for just taking orders and registering people's interest. There was just an incredible amount of interest when the products were launched. A couple million people registered interest in pre-orders before you could actually make orders. So there was quite a backlog of production getting these boards into people's hands. But as production started to ramp up, the backlog started moving down. So I had some numbers from a few months back. Last July, I think they were at about production of about 4,000 boards a day and had about 200,000 boards shipped at that point. The backlog now, there's still some delays, but it's down to a few weeks or possibly less than that from the time you order a board till you were likely to get one in your hands. They also, the first batch of boards were made in China, and they'd wanted to make this a product that was built in the UK since it was designed and the whole program started there. So they're actually doing the manufacturing now, I believe in Wales, for most of the boards. So they've been able to move that into a local manufacturing. So let's talk a little bit about the board itself, what the capabilities are. It's literally a credit card sized board. And I should maybe grab one of the boards here that I've got in case you haven't seen one. But it's a very small device. Also, as you can see in the picture here. So the first thing I want to talk about, where did this name come from, this Raspberry Pi name? It's a really catchy name, but where does it come from? Some of this kind of comes from nostalgia. The early computers from the 80s, a lot of them had names with some kind of fruit in them, most notably the Apple computer, but there were other things out there like the apricot, tangerine, some of the other Apple clones. So that's kind of where they came with Raspberry. And the Pi actually stands for Python interpreter, where Python is really the recommended language to use, particularly if you're a student and you're learning programming. It's good language. It's got kind of a good trade-off between the power of what you can do with it and the complexity of how hard it is to learn. Certainly not the only language, but that's sort of going to be the preferred language for developing educational applications. So I showed pictures of a couple of the computers back from the 80s. The Apple II on the left. Computer on the right was the BBC microcomputer that was popular in the UK, made by Acorn Computers. And Acorn actually evolved into the company that developed the ARM architecture, which is actually where the A in ARM comes from. So there's a connection going back all the way to some of these early computers from the 80s. Also, the BBC microcomputer was available in two different models back at that time, Model A and Model B, and those are also the names of the two variations of the Raspberry Pi. So that also was kind of an homage going back to the BBC computer. The BBC computer, like a lot of the micros of that time, also came with a built-in language a basic language interpreter, which was an easy way to get started with programming. And they ran something called BBC Basic, and that is also going to be available for the Raspberry Pi for people who want to program with that, maybe more for kind of nostalgia purposes. So we'll look a little bit look at the hardware that's on the board. This is kind of a simplified diagram of what's on there. So at the bottom there, the power comes in on a micro USB connector, strictly for power. That's a pretty standardized connector now for getting 5-volt power, so you can use pretty much any standard power adapter like you get for cell phones. To the right of that is the HDMI video connector, also pretty standard for a lot of monitors now as well as televisions. And then there's a standard RJ45 LAN jack for Ethernet, 100 megabit per second Ethernet. And then next to that, 2 USB ports, a few status LEDs. There's a 3.5 millimeter audio output jack and an RCA video jack for a composite video output. Where it says here GPIO, on the actual boards, there's a connector, a header installed on the GPIO connector. I'll talk a bit about that, but that gives you some input-output capabilities if you want to do some hardware expansion, hardware hacking. And then this doesn't really show all the components, but the two major ones in the middle there is the system on a chip, which is kind of a sandwich actually of the CPU and the graphics chip, as well as the memory, sandwiched together, soldered together. And the other major large chip there, I think, is the network controller. So it's a credit card size board. Uses this Broadcom system on a chip, 700 megahertz ARM11 chip. It's got floating point, hardware floating point capability. There's also a GPU that's built in that can do 1080p Blu-ray type quality video, up to a bandwidth of about 40 megabits per second. It's got OpenGL, ES support, and OpenVG. Mass storage is an SD card, so there's no flash on board. It boots from an SD card, but you can use any kind of standard SD card to boot it up, and you can also connect USB storage devices after that if you wanted to, USB keys or USB hard drives. There's actually going to be 2 models offered. The current one is the Model B, which retails at $35. It's got 512 megabytes of RAM. That's actually on the Rev 2 board. They just started shipping last month. Previously it was 256 megabytes, so they've been able to expand the memory to half a gigabyte for the same price. So new boards mostly, I think that people are getting their hands on mostly Rev 2, but there's a lot of Rev 1 boards around. The Model B also has 2 USB ports and Ethernet. The plan is to offer Model A that will be priced about $25, and that allows, they bring the price down a little bit by having only 1 USB port and no Ethernet, and presumably 256 megabyte of RAM, although I'm not sure if that's finalized yet. They may still be able to offer the same amount of RAM for that price. So a little more about the hardware. There's HDMI video out, as well as composite video. So if you've got like an older composite monitor or television, that's another option. Lower resolution, but you've got that option as well. Sound can come out over HDMI, or you can get the sound out of the 3.5 millimeter kind of standard audio jack that's stereo. Will go to headphones or things like powered PC speakers. There's no sound input, but you could use a USB microphone, anything that's got kind of a Linux driver. There is this header connector for the GPIO ports. I'll talk a bit about that later, but that gives you some hardware input and output expansion capability. Adapter through a micro USB connector. It needs about 3.5 watts of power, which is pretty low. So you could run this off of battery power if you wanted. If you want to build some kind of a battery-powered device, if you're doing some kind of embedded or some experiments with robotics or something like that, it's feasible to run it off of battery power. You could connect it to a USB port to pick up power. It's not really recommended. It needs a little more power than you can probably pull from a standard USB port, so that isn't really recommended. So there's no real-time clock or battery backup as a cost reduction, but typically you've got connectivity to a network, and you can sync the time from the network, so that's generally not a problem. There are third-party hardware add-ons you can get if you want a real-time clock and that's battery backed up. The memory is not really expandable. It's built onto the system on a chip, so it's not feasible for the user to expand the memory. So you're pretty much limited to the memory that's there. So again, the retail price is the Model A is planned to be $25, and the Model B, the slightly more functionality, is selling for $35 plus taxes, shipping, and so on. For that, you get basically just this board. So you're typically going to add a monitor, some type, an HDMI monitor, a composite monitor. You're going to need an SD card. You probably want a USB keyboard and mouse and a power supply. All those are relatively inexpensive. SD cards are getting really cheap now. You could use a television if you want for output. You could even get a secondhand USB keyboard and mouse if you want to keep this thing really low cost. Part of the idea is this: you could give this to a student or a kid and let them play with it, and they could feel this is their computer. They don't have to borrow it from their parents and worry about removing software, breaking something on it. It can be their device, and if it gets damaged or breaks, it's not really a big loss. It's a very inexpensive device. The design is mostly open. The hardware schematics are available. There's some proprietary drivers and components related to the Broadcom components. Some of those have recently been open sourced. So it's, I think of all of the system on a chip type devices, this is more open than any other devices that are out there. So you could potentially make clones of the device, I guess, but it'd really be hard to make it cheaper than the price that it's selling for. So for input devices, the most common thing would be hook up a USB mouse and keyboard. You've got two USB ports. You can plug those in directly right into the device. That would be the most common setup. If you want more than two USB devices, you can plug in a USB hub. If you're talking more than two devices, you probably want to start using a powered hub, because you can only take limited power from the device. So if you want to hook up something like a Wi-Fi adapter or Bluetooth, you definitely want to use a powered hub. And looking at output devices, so you typically use an HDMI monitor. You could use a composite monitor, lower resolution, but basically television or an older monitor can be used. A lot of newer monitors have HDMI. You can convert HDMI to DVI with basically a low-cost cable. There isn't really a low-cost solution if you've got an older VGA monitor. There's adapters, but they're relatively expensive. As far as touchscreens, not a lot of options right now. There are some touchscreen monitors that have that basically emulate a USB mouse. Some of those should work if they emulate a mouse. They're going to be limited in how much touch capability you've got, because they're really kind of emulating at a mouse level. There are some devices starting to become available. We've been experimenting with something from a company called Chalkboard Electronics. They have a 10-inch touch screen is kind of a bare touch screen like you'd have in a tablet. And most of these use the hardware offer a small adapter board that adapts this LVDS protocol from the touchscreen to. So that's something we've been looking at. We actually got some of the hardware here this week and may have that demo, something we can demo in the ICS booth for that. We've also been looking at some particular touchscreen monitors that work for a larger screen. I think the Dell 2220 is one that we've been looking at, and that will work. There's some kernel drivers that you need for it to get it to work, but that's another option that's known to work. Other than that, there aren't really too many kind of turnkey solutions for touchscreens right now, but I'm expecting there'll be a lot more coming out in the future as the kind of more third parties start offering add-ons for the Raspberry Pi. So I mentioned this GPIO connector. This is interesting, particular interest to me because I like to do a little bit of hardware development and hacking, and this gives you what's called GPIO or general purpose I/O ports. So you've got analog and digital inputs and outputs. You've got some digital inputs and outputs. There's a serial port on this connector that is basically your serial console when you boot up. Also supports some other protocols like SPI and I2C. So these come out on a connector that's provided on the board that you can use to expand this and hook it up to other devices. I recommend using a bit of caution. These go directly into the system on a chip, and there isn't any kind of protection. So if you're not careful and you generate too high a voltage going to this thing, you can blow up the CPU. It runs on 3.3 volts, for example, and it isn't really tolerant of 5 volts. So I'd recommend putting some kind of protection between the I/O pins and any hardware that you build. Some of the third-party add-on boards that I'm going to mention later will do that. There's a couple of other connectors on the board. There is an interface for cameras, basically webcams. There's a standardized serial interface for that, and there's a connector on the board for that interface, and this is planned to be used for a camera that's going to be offered as an official camera module for the Raspberry Pi. There's also a DSI interface that's meant for driving LCDs, which down the road may be usable for driving LCDs, but right now there doesn't seem to be any Linux drivers for it. Some of this is proprietary to Broadcom. And if you're looking at the kind of the low-level hardware, there's some differences between the Rev 1 and Rev 2 boards in terms of the pinouts on the connector and some of the capabilities. So you may need to check the documentation on that if you're doing some hardware interfacing. There's a few little changes. They've mostly brought out a few more pins and capabilities on the Rev 2 board. So we'll talk a little bit about third-party hardware and things that are becoming available, particularly for hardware expansion. And I've shown a few pictures of these. On the top left is something called the GERT board, which is an input-output board that provides buffering and gives you more input-output ports. It's got an analog to digital converter, digital to analog converter. It's got some push buttons and LEDs, provides isolation between the hardware you're interfacing to and the Raspberry Pi. This was developed by one of the colleagues of the guy at Broadcom who designed the Raspberry Pi. This is currently available from Element 14, which is one of the Raspberry Pi manufacturers, and it's currently a kit, but likely over the next month or two they're going to be moving this to an assembled board. It's a somewhat challenging kit to build because it's got a number of surface mount parts that you need to assemble. I think I'll talk a little bit more about that later as well. There's a number of devices out there. On the upper right is something from the company Adafruit, which sells some kind of hobbyist electronics kits and components and add-ons. This is a expansion board that plugs into the Raspberry Pi that they call the Pi plate, that gives you access to all the I/O pins and some prototyping area where you can build circuitry, or even, as I'm showing here, you can put a little solderless breadboard on there and do some interfacing. This is kind of similar to the concept of the Arduino boards, which is a low-cost microcontroller that have what they call shields that plug into the Arduino and allow you to expand the hardware capabilities. So this is kind of a similar approach. Something else you don't get with the Raspberry Pi is any type of case. So it doesn't look particularly good, and you've got to watch that you don't short it out or break any of the components off. So a lot of people would like some kind of case for the device, and there's a whole bunch of third-party cases that are becoming available. There's a couple I've shown on the bottom here. The one on the left, I think, is from Adafruit. That's a laser-cut plexiglass case, and there's another one on the bottom right here. But there's lots of different cases out there, whether you want plastic or metal or wood. There's a whole bunch of options out there. So we're kind of starting to see kind of an ecosystem of third-party add-ons for the Raspberry Pi, a lot like we're seeing in the Arduino community. So some of the other hardware, and some of this I've mentioned, there's an official camera module coming from the Raspberry Pi Foundation. They've demonstrated this. It's expected to cost about $25. It's going to be using the same kind of technology that's in webcams and the built-in cameras that you see on laptops. So these things are really small, and they're getting to low cost now. And this should be able to do 5 megapixel images and video, and it's going to connect to the CSI port that's on the board. So that should be quite interesting. As I mentioned, there's various extension boards for the GPIO. So I mentioned the Pi plate and the GERT board. On the lower right here is something called the Pi cobbler that lets you bring the GPIO connectors out and plug them into a solderless breadboard if you want to do some prototyping and experimenting. We're expecting to see more LCD display options come out and touch screens, lots of third-party cases, and then just all kinds of new things. If it's like the Arduino, there's going to be all kinds of different expansion boards that people think of that become available. So we've been looking at the hardware. Let's talk a little bit about the software capabilities and what's available. The initial and kind of the recommended operating systems are all Linux-based, and the recommended one from the Raspberry Pi Foundation is a Debian-based distribution that's called Raspbian. It's actually an early version of the next Debian release, which is codenamed Wheezy. This particular build or variation of Debian is quite nice because it makes use of the hardware floating point capability that's on the ARM processor. So it gives a little performance boost over the previous version that was doing software floating point emulation. There's a lot of other Linux distributions out there. I'll mention a few of them. But there's lots of Linux distributions that run on ARM, and a lot of them have been imported to the Raspberry Pi. The recommended distribution could even change over time, but currently it's Raspbian for kind of general purpose. And I mentioned briefly the code for the GPU and some of the other Broadcom hardware was totally proprietary, but they've started open sourcing that as of last month. I'm not sure to what degree it's all open source, if it's totally open sourced or not, but it's certainly more open than really any of the other kind of system on a chip products are, because they tend to have proprietary drivers, particularly for the graphics processor. There's also ports of some other applications, and I'll mention some of these later. I looked briefly just last week at something called Risc OS, which was running on the Acorn computers back probably in the 90s, and that has sort of continued to evolve and run, and that's, I think just about a week ago they made available an image of that, so that's kind of an interesting operating system with a graphical user interface that's not really derived from any other operating system that's out there. There's also an Android port coming. I'll mention a little bit about that later as well. So as I started off by talking about how the Raspberry Pi was really designed as an educational platform, and that's where they want to eventually get. Currently, it's more of a platform for software developers who want to start developing applications that are going to turn this into an educational platform, or for totally different applications like embedded applications. But the current software, if you look at Raspbian, for example, is mostly aimed at developers who want to develop code, although there are some educational apps showing up. And as I mentioned, the kind of the preferred language for educational apps is Python. Again, it provides a good balance of something that is relatively easy to learn but still quite powerful. And we're starting to see some interesting development tools that are suitable for young people that don't require you to really know everything about programming, but let you get started with doing kind of graphical programming and then kind of move to Python programming and maybe other languages in the future. So I've actually seen some games that kids that are maybe 5, 6 years old are actually writing their own games with some of these tools, and it actually looked pretty cool. I'll mention, I think in a later slide, some of the other operating systems that are being ported. The one that probably won't run on this hardware is Windows 8. It's going to need a more powerful ARM chip to run the WinRT version of Windows 8. So that seems pretty much not possible on this current hardware. So it doesn't look like there'll be a solution for running Windows apps. There's something called Wine that runs on Linux that can run Windows apps. But it needs to be running on an x86 CPU in order to run x86 Windows apps. So that doesn't really look like that's feasible either. So I'll talk a bit about the Raspbian distribution. This is currently the preferred Linux distribution. A few months back there was another that it's newer and it's been optimized more for the Raspberry Pi hardware and makes use of the hardware floating point capability that's there. So that gave a performance boost. This is based on the next release of Debian, which when Debian 7 comes out is going to be kind of the next release of Debian for all the different platforms they support. The default desktop, it's running X Windows and it's running LXDE, which is a lightweight desktop environment that runs pretty well on this kind of system that's relatively limited in memory and CPU capability. So it's Debian. You've got access to pretty much all the Debian software packages. There's something like 35,000 packages out there. Most of them are available, have been built for the hardware. So there's a huge number of packages out there. And if you're more familiar with Ubuntu and hadn't heard of Debian, Ubuntu is derived from Debian as well. So it's very similar, based on the same core operating system, the same packaging format. So finally, we get to talk a little bit about Qt on the Raspberry Pi. The initial version of Qt was something called the QtonPi Linux distribution. That was a separate distribution that included Qt. This was focused on Qt 5 and gave you an operating system image and a version of the Qt SDK, basically Qt Creator, Qt itself, that would run on a desktop and allow you to do development. So there was an image that you could burn onto it. You could write to an SD card and boot up. This was based on Fedora Core. This was kind of what the initial people ported Qt to were using, but after a while it kind of became obvious that a better solution was to move all of this work into the standard distributions that are running on the Raspberry Pi. So these have started moving into Debian. The version previous to Raspbian, which was called Wheezy Beta, some Qt5 packages were built and made it into that. They aren't yet in Raspbian, but that will hopefully happen before too long. And I'll get back to Qt again, but also just wanted to mention some of the other Linux distributions. This company, Adafruit, which sells products to electronics hobbyists, they offer a lot of things related to the Arduino microcontroller, and they've started offering Raspberry Pi products. They've actually built their own Linux distribution that's a little more optimized for people that want to play with hardware and learn about electronics, called Occidentalis. And the interesting feature of this is they've developed an IDE that runs on a desktop in your web browser that lets you write code in a number of different languages, compile it if it's a compiled language, and then deploy it to the Raspberry Pi and run it. So that's an interesting product. There's a few other Linux distributions like Arch Linux. The older Debian port was Debian Wheezy that did software floating point emulation. There were a few applications that haven't yet been moved over to Raspbian, so that's still available if you need to run that for some particular apps. So getting back to Qt, back in 2011, Nokia and ourselves at ICS saw that the Raspberry Pi looked like a really good platform for kind of using as a reference platform for embedded Linux, something really inexpensive that developers could get their hands on and play with embedded Linux and not worry about having to buy really expensive development boards. And this was a way to help kickstart Qt5 as it was getting closer to release. We worked with Nokia to develop this QtonPi device program where we got access to 400 of the early boards coming from the Raspberry Pi Foundation and allocating these to people who had interesting things they wanted to do related to Qt on the Raspberry Pi. So we took basically submissions from developers who had an idea of something they wanted to do with the Raspberry Pi. It didn't have to be ambitious. Maybe they wanted to experiment with WebKit or do some optimizations for Qt Creator. So developers were selected for this, and boards were allocated to them. And we had actually hoped, I think just at almost exactly a year from now, to get our hands on some of the early boards quite quickly. But the combination of the moving the hardware development to some distributors, that slowed things down. So the actual boards didn't get into the developers' hands till about August of this year, but that eventually did happen. So on we'll talk a bit about Qt4, and then we'll talk about Qt5. So there is a port of Qt4 on the Raspberry Pi, and this is really just kind of a port like any other X-based Linux distribution. The packages are available in Raspbian, pretty much the standard Debian Qt4 packages. This doesn't make use of any hardware acceleration. It's just using X. But it runs okay in my experience for apps that really aren't too big. I'll show a demo of an app running that. So that is available if you want to play with Qt4. Isn't particularly interesting, but it runs like other desktops, a little slow. But most of the development work is focused on Qt5, where we could leverage the using the new QtQuick 2 scene graph capability to move a lot of the the rendering work onto the GPU chip and use OpenGL, so we could leverage a lot of that and not rely on the relatively slow CPU that's on the Raspberry Pi. So that's there. If you were porting something that you wrote with Qt4, maybe from a mobile device or something like that, you might have used Qt Mobility, which is an add-on in Qt4 that gives you add-on things like location services, access to things like address book, network information. This wasn't ported per se to the Raspberry Pi, but basically builds out of the box on any Linux distribution. So if you wanted Qt Mobility with Qt4, you could build it yourself. I didn't have any problems building it. There are some portions of it that just aren't relevant, like say GPS. Don't have GPS hardware, you don't have accelerometers, so those modules won't be built in. Only comment would be that the last Qt Mobility release goes back quite a while. I think the 1.2 release, so you probably want to build from Git because there's some issues, just kind of bit rot from the code being old, and some compile issues since changes to compilers since then. But the current source seems to build fine. In Qt 5, as you may have heard in some of the other talks, mobility, much of it is moving and is in Qt 5, but rather than a separate Qt Mobility module, these become new modules in Qt 5 that are available for the most part. So talking a bit about Qt 5, Nokia sponsored some of their developers and third-party people. ICS did some of the work to get Qt 5 running well on the Raspberry Pi, and this went way back to 2011 when some of the really early boards were available. I think we only had like 1 or 2 boards in total for a while. So this can use Wayland. I'll talk a bit about that later. And then they got things like using hardware accelerated cursor working, getting multimedia working using GStreamer and some of the underlying libraries provided on the Raspberry Pi. Video playback. There's an issue on the Pi, like a lot of Linux distributions. Some of the video formats are proprietary and require licensing, patent issues. So there's a limited number of video formats that are supported, but you can actually now you get support for a couple more formats by buying codecs that you can get from the Raspberry Pi Foundation. You have to buy a license per device for these additional codecs. I think I mentioned that in a later slide. It's like a couple British pounds per device if you want support for the other codecs. Some of this, I think, was really driven from Nokia because the hardware on the Raspberry Pi was very similar to a system on a chip that they were using, looking at using on their next generation of Qt-based phone. So this would be a way to really get people familiar with this hardware and then be able to develop on some of the Nokia devices. So those didn't actually materialize, but that was part of the original thinking. So as I've mentioned, the Qt 5 packages hopefully will move into the Raspbian before long. There's some things that have not yet been packaged, but are getting there. But currently you can use it. There's information on the Qt Project Wiki about how to build Qt 5 from source for the Raspberry Pi, where to get the tool chain. And there's a nice script called Bake QtPi that will actually do all of these steps, go out and get the tool chain, check out the Qt 5 source from Git, cross-compile it on a desktop, and provide everything you need to build it for a Raspberry Pi and to do cross-compilation on a desktop. You can use Qt Creator too then, if you want to use it as your IDE, you can use that like any other embedded Linux to cross-compile and deploy the code out to the Raspberry Pi. So a little bit about some of the back-end stuff, but I won't go into too much technical information. Right now, the OpenGL, ES, and full screen, so everything's drawn to one surface. There's no window manager. It's you can only run one application instance. It's not actually going through X11, so you can be running this whether or not the X11 desktop is running. There's some work that's been done to get the Wayland compositor working, so that will allow it to play nicely with X11 in the window manager, so that you have multiple applications working in unison, multiple windows and so on. There's a bit of work to be done there. I think the Wayland was only, the Wayland 1.0 release I think was only a couple of weeks ago, so it's just now that they've finalized all of the protocol. So there's a little bit of work I think needs to be done to bring the back-end code up in sync with the latest Wayland and get that all working nicely. So that will allow kind of more like desktop applications to work a little better. The XCB backend, which is what you normally use for X11, doesn't have OpenGL support, so that option doesn't work if you want to use QQuick 2. So that isn't really a great option right now, because most people want to look at the newer stuff that's available with Qt 5. So I'll talk a little about some of the other boards that are out there. I'm kind of looking at the Raspberry Pi as more of an embedded device. Some people think of more of a desktop, but to a lot of us, this is more of an embedded platform. So there's other things out there, things like the Beagle board. I think that's about $150, so it's a little more expensive, has a little bit more hardware on board, is also ARM-based, so that's certainly an option. The Arduinos are a much simpler device. It isn't really running a full operating system, but you can do kind of more real-time stuff with an Arduino. There's some others I've seen I haven't really played with. VIA has something called the APC that runs Android, and I expect there to be a lot of other devices coming out. A few other things kind of in interest. There is a video player application that's installed out of the box in the standard distribution that lets you play videos, and I'll do a quick demo of that. ICS has also been doing some work recently to wrap the OMAX media libraries in Qt so that you can do some multimedia stuff within Qt, and we're working on getting some demos running with that. As I mentioned, you can buy licenses for some other codecs. So if you want support for Microsoft's codecs or MPEG-2, you can buy a per device codec from the Raspberry Pi Foundation, and that will unlock some of the capability that's there in the firmware. So the Raspberry Pi's got on the newer boards 512 meg of RAM. That's actually shared between the CPU and the graphics chip, and you can adjust how that is split. So if you had like a headless application where you don't care about video, or you're doing very limited video, you can give some or all of the RAM to the CPU. If you're doing more multimedia related stuff, then you probably want to provide more RAM to the GPU. The default is a 50-50 split, but it's configurable. And you can do this now with the Raspberry Pi config program. The most recent one, you can specify exactly how you want to split the memory. You have to do that it's configured at boot time. You can't do that on the fly. If you do any development on the Raspberry Pi, so you're running a full Debian system, you can do compiling natively, but you're going to find it's very slow because you've got a slow CPU, relatively slow file system. I think someone estimated that building Qt 5 on a Raspberry Pi would probably take about a week. And so you want to cross-compile it on typically a Linux desktop. There's a tool chain available. You can check the Qt project wiki pages, and they'll tell you how to do that. There's also a QEMU emulator. I haven't really looked at that. It can emulate Raspberry Pi. I'm not sure how useful that is. And for SD cards, you can use standard SD cards. There were some hardware compatibility issues with the early versions of the Raspberry Pi that they've mostly fixed with some of the firmware updates. But there's some, you want to use a reasonably good quality SD card so that you get decent performance. You can also overclock the Raspberry Pi, which is kind of cool. In software or in its firmware, you can increase the clock speed. It's rated at 700 megahertz, pretty conservative. It'll run at 700 megahertz with no fan, no heat sink, but you can overclock it up to a gigahertz, and you can overvoltage it to run a little higher. Initially, this was frowned upon, and if you overclocked it or if you overvoltaged it, you would actually violate the warranty. But more testing, they found that it's reasonably safe. Worst case, you might see some corruption if you really overclock, and storage with USB devices. Wi-Fi is not built in, but there's support now for some of the common USB Wi-Fi adapters. As far as documentation, there's a whole community with forums, wikis. There is a official book out now that's available in print or ebook, and there's a monthly magazine that's a free download. And there's also various contests running. So we're almost out of time, so I'm going to run quickly through a few more here so I can give a quick demo. A port of Android has been demonstrated, and it's expected to be available maybe sometime next year. The Model A, the lower cost version, isn't available yet. Presumably will be coming out next year. And eventually, I think you're going to see like an educational version where you can buy a computer in a case with keyboard and mouse, and it's like a commercial consumer product that would be something that students could buy. So to simplify the demo here, it's a little awkward to run the actual Raspberry Pi from there without being able to see the screen. So I've actually recorded a video earlier that we can look at. It's not great quality. It's recorded with a digital camera, but I'll just show quickly 2 or 3 minute demo of some of the things that it can do. This is booting up what you see on the console. It's reasonably fast at booting. You can configure whether you want to boot into a graphical desktop or whether you just want to stay with a text console if you're not doing any graphical stuff and want to save some memory. It's probably like about a 15-second boot or so. So this is booting up into the LXDE desktop, which is running X Windows. Should come up momentarily. Okay, so I launched a few examples here from a remote SSH session. So I think the first thing was the media player that is installed out of the box. It's not a Qt-based media player, but the same multimedia library can be used from Qt. So that's coming up now. So this is just running a little open source movie. So you could probably see from here, you get a good 60 frame per second frame rate. It's not using the full CPU. It's offloading a lot of this to the graphics chip. I think the next thing I briefly just fired up a Qt4 application, desktop application. This was a spreadsheet app that's actually in the Qt4 book, the official book on Qt4. It's a reasonably typical desktop application of a few hundred lines of code that implements a spreadsheet and has most of the basic capabilities. So this is running Qt4, doesn't use any hardware acceleration, but runs reasonably well, and works well in the X Windows environment. So that is an option. And again, that's pretty much the standard Qt4 built for X Windows on Linux. Next, I've got a few Qt5 demos. Kind of ran some of the standard demos, some of which demonstrate some of the OpenGL stuff. So this was actually shown in the previous presentation by Lars. This is one of the games, same game that was written. This is one of the Qt examples. So it's running here full screen. Just takes up a corner of the window, but the performance is pretty good. It's kind of what you'd expect on any other device or a desktop, and that's all in Qt Quick 2. I think a few more demos here that this is a little, I think, photo viewer that brings up some digital camera images, lets you browse through them. And again, performance looks pretty good. I think I'm going to skip ahead to running out of time here to some of the OpenGL demos. So the quality actual demo here is not too great, but you can see some of the demos that you may have seen running on desktops for Qt5 that are using Qt 2 with OpenGL, and you can see getting good frame rate, and it's not really using that much of the CPU. So I'm just going to go back to my slides here because we're running out of time. So wrapping things up, here's some references to the major sites. RaspberryPi.org is the main site for the Pi. QtProject.org has some wiki pages telling you how to build Qt, how to run it on the Raspberry Pi. The script I mentioned that can build Qt5 is listed here, and also the Raspbian distribution. That's the main site there. So there's a lot of pointers there that will take you to forums and wikis and so on. So in summary, hopefully you saw the Raspberry Pi is a really low-cost computer. It's a great platform for Qt5 development, experimenting with embedded development, $35 device. So it's a good way to get started and get your hands on something and play with embedded development. Can use more volunteers. It's kind of lost a little bit of momentum as we lost some of the Nokia people that were working on this, so we can definitely use some help for people to help packaging and testing, and also just to start writing applications using Qt on the Raspberry Pi and make that one of the popular frameworks to use for applications.
Thank you, Jeff. We can open up for questions for a few minutes.
Is the Raspberry Pi powerful enough to run Qt Creator and at least debug the applications on the device?
I have fired up Qt Creator and it seemed pretty reasonable, but I haven't used it for real development. You have GDB on there, so I think it should be feasible. But most people would probably run it on a Linux desktop and remotely talk to the debugger on the Pi and use, if you want to use the Qt Creator debugger GUI, it's probably better to run on a Linux desktop. But you can do it in a pinch if you need to. The same, you can compile things, a small app if you really need to on the Raspberry Pi if you had to.
And you were talking about playing with the device, about young people and students, but how do you see the chances of deploying that device in industry, or with other words, how robust is the hardware? Can it run continuously for 5 or 10 years? What are the temperatures in which it can run?
Okay, I don't have specific numbers on that, but what I'm hearing is it's pretty robust. There's it seems to be quite over-designed. There's no fan, no heatsink. If you run it at the rated clock speed, it seems to be pretty robust, but it still kind of remains to be seen. I know, like without a case like this, if you just bang it around and carry it around, some of us have broken the devices because they're not in a case. But it seems to be suitable. But that's kind of remains to be seen and depends on the application, I guess.
There are Qt5 libraries in VC beta, but there is no QML viewer or QML scene binary. If there would be one, you can just develop with a text editor QML files.
Yeah, currently that script and things that most people have built, that they're not building the QML scene. I've actually built it myself. It's not that hard to build, but it's definitely one of a good task would be to expand the builds that we currently have so that you've got QML Scene and QML Viewer. But you can certainly build it and then run it on the device. I've done that, but we kind of need to publish the instructions and make that easier. And I'm sure once it gets packaged for Debian, those will be there.
I think that's pretty much all we have time for. Thank you very much again for Jeff. Thank you.
Thanks for listening.
Next.